Hey everyone, in this video I want to go over how to factor perfect square trinomials and a difference of squares. So first let's talk about perfect square trinomials. So you might remember in one of the previous videos that a perfect square trinomial can be written in the form a plus b squared, a binomial squared. And when you square this binomial, after using FOIL and expanding and combining like terms, you get a squared plus 2ab plus b squared. So this is a perfect square trinomial, this one right here on the right, because it can be written in this form, which is a binomial squared. Therefore, it's a perfect square. And let's talk about this trinomial right here, 9x squared plus 12x plus 4. So first, let's determine if this is a perfect squared trinomial. And if it is a perfect square trinomial, then we can write it in a plus b squared form. And that is how we will factor it. We leave it in this form, and that is how we will factor this trinomial. So first, let's see if it can be written in this a squared plus 2ab plus b squared form. So if it can be written that way, then let's write it out. What is a squared supposed to be? So a squared, this first term right here, that is supposed to translate to this 9x squared. 2ab is supposed to translate to this 12x. And b squared is supposed to translate to this 4, positive 4 right there. Excellent. So let's scroll down a little bit. And let's go ahead and see if we can write it in that form. So if a squared is 9x squared, what is a? How do we write this? So we want to write this as a squared, but what is a? So a squared, well, if a squared is 9x squared, then a must be, if you take the square root of both sides, must be the square root of 9x squared. And what's the square root of 9x squared? Well, using the quotient rule for radicals, the square root of 9 is 3, times the square root of x squared, which is x. Therefore, a is 3x. So let's write 3x over here. And let's erase some of these. Excellent. And before we get to this middle term, let's actually do the last term, the third term, positive 4. So this is supposed to be our b squared. So b squared is supposed to be 4. What is b then? Well, we'll take the square root of both sides. B is the square root of 4, which is 2. Perfect. So let's write that in. B is 2, so 4 can be written as 2 squared. The b squared in this situation. So we have our a squared, which is here. We have our b squared, which is here. And now let's write down our 2ab. So our 2ab, so plus 2 times a times b. And let's just move this 2 squared a little bit further. Let's move it right there. Just make it a little easier to read. Plus. Excellent. So what is our a and b? Well, we have them right here. Our a is actually this 3x that we had right here. And our b was this 2 that we had right here. Excellent. So 3x squared plus 2 times 3x times 2 plus 2 squared. So this indeed can be written in a squared plus 2ab plus b squared form. It can be written that way using integers. If it wasn't a perfect square trinomial, then we would have issues writing this because the numbers we would get for a and b would not be whole numbers. They would actually be radicals. So just to show you a quick example, if we tweak this even a little bit, if we called this 8x squared, that makes finding a lot harder, because if a squared is supposed to be 8x squared, then we get a square root of 8. We can take the square root of x squared, that just gets us to x, but we would have a radical 8. So we would have a radical as as either a or b. We would have a radical in a in that case. So if we replace this with an 8, that would make it not a perfect square trinomial. But having it be 9, which itself is a perfect square, because the square root of 9 or radical 9 is 3, makes this trinomial a perfect square trinomial. Okay, excellent. So let's erase these. And we were able to write it in this form, a squared. So just again, a squared plus 2ab plus b squared, without any issues, no radicals. Therefore, we can say that since, let's erase all this. Since all of this is a perfect square trinomial, we can factor it to a plus b squared. So a plus b squared. And what is a? We said that was 3x. So a is 3x. So 3x. And what is b? We said that was 2. So b is 2. 3x plus 2 squared is the factored form of this perfect square trinomial. So that's how we factor perfect square trinomials. And now let's scroll down and talk about factoring differences of squares. So a difference of squares, just as a reminder, can be written in this form: a squared. Let's just make it different colors. Let's separate this. So we could write it as a squared minus b squared, and that equals a plus b. So a plus b, let's actually just write it like this: a plus b times a minus b. So to factor a difference of squares, first we have to identify, is it in the difference of squares form, a squared minus b squared? And if it is, then we could write it in this factored form. We know how to factor it already, because a squared minus b squared is simply just a plus b times a minus b. Okay, excellent. So let's scroll down a little bit, and let's go through an example together. Let's say we had 16x to the fourth minus 36, and we wanted to factor this into two binomials. Well, we can recognize this as a difference of squares. We recognize this as a difference of squares because if we take a look at its a term, what is a in this case? So a squared minus b squared. What is a equal to? Let's start with that. What is a? So we know this first term right here, 16x to the fourth, that is a squared. So again, a squared equals 16x to the fourth. Perfect. But now what is a then? Well, we can take the square root of both sides to find a. And let's do it. What's the square root of 16? That is 4. And what's the square root of x to the fourth? That is x squared. Okay, so we know a is 4x squared. So 4x squared. Excellent. And let's do the same thing to find b. So we know this term right here, this second term, negative 36, or just ignoring the negative sign for a second, just the 36. Our second term is 36. That is the b squared in this case. So b squared is 36. Now what is b equal to? You take the square root of both sides. What's the square root of 36? That is 6. So our b is 6. So there we go. We're able to write it in a squared minus b squared form. So we know that this is a difference of squares. And since this is a difference of squares, we're able to write it in this factored form right here, a plus b times a minus b. So let's go ahead and do that. What's a? A was this 4x squared. So 4x squared. And then plus, and what is b? B is the 6. So plus 6 times a minus b. And what was a again? That was 4x squared minus b, which is 6. So again, the b right here is that b, that's that b, that's that a, and that's that a. Excellent. So that is the factored form of this trinomial, or of this difference of squares, rather. There we go. So 16x to the 4th minus 36 factored gives you 4x squared plus 6 in parentheses times 4x squared minus 6 in parentheses. Perfect. So that is how you factor a difference of squares and perfect square trinomials. I hope this video helps, and please let me know down in the comments below if you have any questions. Thank you for watching.